Question 13, Electronics and Communication Engineering, GATE 2015 Set 1. In the circuit shown, the switch SW is thrown from position A to position B at time t equal to 0. The energy in microjoules taken from the 3-volt source to charge the 0.1 microfarad capacitor from 0 volt to 3 volt is dash. 4 options are given to us, and for a detailed lecture on this concept, please refer the NPTEL video, Module 1, Lecture 17, RC First Order Circuits, Complete Response with Step Inputs, Transient and Natural by Professor Nagendra Krishnapura, Department of Electrical Engineering, IIT Madras. Let's have a look at the basic concepts required to solve this problem. Consider that we have a RC series network. This is excited via a switch which is thrown at time t equal to 0. Consider that the voltage that is supplied is Vs of t between these two ends. At t equal to 0, this switch is thrown. The voltage across the capacitor will transient from the minimum voltage. The value of the transient state voltage is given by the steady state voltage, which is Vc infinity, plus the transient voltage. The transient voltage is Vc0 minus Vc infinity into e to the power minus t divided by tau, where tau is the time constant of the network, and this time constant is equal to R multiplied by C. With this concept in mind, let's solve this problem. The switch is in position A till time t equal to 0. So, we can understand that before the switch is thrown, Vc0 minus, or the voltage of the capacitor before it is connected to the 3 volt source, is equal to 0 volt. So, this capacitor is uncharged. At Vc infinity, the voltage across this will be 3 volt, because at infinity the capacitor will be reaching the steady state and it will be replaced as an open circuit. The entire 3 volt that is supplied will appear across this ends. Therefore, Vc0 minus is 0 volt and Vc at infinity is equal to 3 volt. There is a transient stage between the 0 volt to 3 volt, and this is defined by the time constant tau, which is R multiplied by C, 120 into 0.1 microfarad, which is equal to 12 microseconds. Therefore, from the formula, Vc of t is equal to 3 plus 0 minus 3 into e to the power minus t divided by 12 microseconds. So, this is equal to 3 into 1 minus e power minus t divided by 12 microseconds. This is in volts. We are asked to find out the energy in microjoules that is taken from 3 volt source to charge this capacitor from 0 volt to 3 volt. The energy that is supplied by the 3 volt source is asked. This energy is equal to the energy that's dissipated across the resistor plus the stored energy in the capacitor. This can be found out by V square divided by R or I square into R, and this energy is given by half CV square. At steady state, this would have charged up to 3 volt. Therefore, V square is equal to 9 volt. So, the energy that is stored is equal to half of 0.1 microfarad into 9, which is equal to 0.45 microjoules. Now, let's find out the energy that is dissipated across this resistor. This voltage is a function of time. This can also be said as I of t whole square times R. This current is same as the current across the capacitor as well as the resistor. The current that's flowing through the capacitor is given by C into the differential of the voltage across the capacitor. This is equal to 0.1 microfarad times the differential of this voltage. This is equal to minus 3 e to the power minus t divided by 12 microfarad times minus 1 divided by 12 microfarad. This is equal to 0.025 e power minus t divided by 12. This current can also be written as 25 e power minus t divided by 12 micros milliampere. This current will be same as the resistor's current I of t. is equal to 25 e power minus t divided by 12 micros milliampere. Therefore, the energy stored in the resistor from the limit 0 till infinity is given by limit 0 to infinity 25 e power minus t divided by 12 micros whole square times the resistance 120 ohm. 75,000 from the limit 0 till infinity e to the power minus t divided by 6 micros, and the unit is in microjoule. So this will be 75,000 into e to the power minus t divided by 6 micros divided by minus 1 by 6 micros from the limit 0 till infinity. The unit is in microjoule. This will be e to the power minus infinity will be 0 minus of minus 1 into 10 to the power minus 6 microjoule. So this will be 0.45 microjoule. Now we have found out the energy that is dissipated across this resistor and the energy that is stored across this capacitor. Adding both of them, we will get the supplied energy. Therefore, the energy that is supplied will be 0.45 microjoule plus 0.45 microjoules. Therefore, the energy that's supplied is equal to 0.9 microjoule. The correct answer is option C, 0.9 microjoule. Thank you.